Homework 21, Hypothesis Test for Population Proportion, Video 3. As I mentioned at the end of the previous video, I'm only doing one more video to illustrate the p-value approach because just like the hypothesis test for population mean, the approach is identical with one exception, how you calculate the test statistic. But the way you calculate the test statistic is the same that we just did in the previous two videos. So this is just shifting gears a little bit, but it's not really any new content at this point. And again, this is the exact same example as before. We already know the answer to the question is no, but let's pretend we didn't know that yet. A magazine reports that 73% of companies have Twitter accounts. That's a claim about a population proportion. A reporter thinks this number has changed. She surveys 50 companies and finds that 36 of them have Twitter accounts. Can she conclude at 10% that this number has indeed changed? Actually, I am going to make a subtle change. Let's pretend that she accidentally said 36 when she meant 31. Because I don't want her to be exactly the same. She surveyed 50 companies and finds that 31 of them have Twitter accounts. Can she conclude at a 10% significance level that this number has indeed changed? I don't know how this is going to turn out because 31 out of 50 is 62%. That's 11% less than that. That's a big change, but is it a big enough change? Now, remember that the p-value approach starts the same as the critical value approach, stating the hypotheses. But the next step is to jump directly to the test statistic. And since I changed the p-hat value, I'm going to have to recalculate the test statistic. The p-hat value is now 31 out of 50, which is 0.62. Let me pause for a second. I'm so guilty about just running off and gaining momentum. I sometimes forget to say, you might want to pause and try this problem. So I'm going to invite you to pause right now, calculate the value of the test statistic. And if you want to push it all the way to the end and calculate the p-value, I invite you to do that as well. But I'm going to throw away my empty Sonic drink that I've had for 4 hours now. Okay. If you paused, great. If you didn't, it's your decision. All right, so our test statistic is not p-hat equals 0.62. That's a piece of the formula that we need. We also need sigma sub p-hat, which is actually the same as it was before, because the formula for sigma sub p-hat requires knowing this and the sample size, which did not change. So 0.73 times 1 minus 0.73 over the sample size. I think it was 0.0201, but I don't remember. So 0.73 times 0.27 divided by 50, square root. No, that must have been a different problem. It was 0.0628. I remember that number now. Glad I recalculated it. And so our test statistic, converting the p-hat, is what we got from the sample, 0.62, minus what we're claiming in the null hypothesis, 0.73, divided by the standard deviation of the sampling distribution of the p-hats, divided by this, 0.0628. So let's see what that z-score is. That z-score, 0.62 minus 0.73, divided by 0.0628 is negative 1.75. Now because I did the critical value approach earlier, I already know what's going to happen because I remember what the critical values were. I want you to pause and think about it for a second. If you watched the previous video, do you remember what the critical values were? And do you remember what it means if this number is negative 1.75? But we're talking p-value approach, so let's calculate the p-value. Remember, the p-value is the area of the tail or tails cut off by the test statistic. Now, whether it's tail or tails depends on what type of test it is. So we still need to look at the alternative hypothesis and go, you're a two-tail test, so we're going to cut off not one tail, but two tails. Now, we only have one test statistic. It should be either positive or negative. If it's 0, shut the whole thing down, because if it's 0, that means that this matched this, and there's no need to test. But our z-value is negative 1.75, so that's the left tail's z-value. And to pick up a two-tail test, we need the positive z-values over here. And remember that the p-value is the area of the tails. We only need to look up one area because they're equal. Thank you, symmetry. So we'll go to the negative 1.7 row in the z-chart in the 0.05 column. I'm not going to sketch it up there because if you haven't looked at the z-chart by now, by the last video of the class, I don't know what to tell you. All right, so negative 1.7 row, 0.5 column, 0.0401. 0.0401. So this area is 0.0401, and this area, being equal, is also 0.0401. I snickered because when I was a kid, my first home address was 401. I'm not worried about you using that to crack any password recovery questions because I don't ever use that. So the p-value is the total area of the tails, so 2 times 0.0401, which is 0.0802. And now, we have to make our decision. Remember, the decision in the p-value approach is based on comparing the p-value to the significance level. Our p-value is 0.0802, which is 8.02%. Is the p-value greater than the significance level or less than? It is less than. Because the p-value is less than the significance level, that means that we reject the null hypothesis. So can she conclude that the number has changed? Well, if we reject the null, we're concluding the alternative, and yes, we can. So the p-value approach, again, is the exact same as it was for testing a population mean, with the exception of how you calculate the test statistic. But set up hypotheses, make note of left, right, or two-tail, calculate the test statistic, draw a picture of the test statistic, cutting off a tail, but if it's a two-tail test, then you have to cut off two tails. Use the z-chart to find the area of one, or in this case, both tails. And the p-value is the total area of the tails. If the p-value is too small, reject the null. In this case, too small meant less than 10%. If the p-value is greater than the significance level, then you would not reject. And that's it. I want to say my video count for the semester for all my classes is approaching 360. It's a lot more than I thought it would make, but I've enjoyed them. I hope some of you have watched them, and I hope that you learned something from them. I do want to remind you that your final exam is not cumulative. It is over homework 21, homework 20, and homework 19 only. So it'll be a fairly short final exam. And as with all other tests, you need to write down all of your work and send me pictures of it so that when I grade your final, if you miss any question, I can look at your work and possibly award you partial credit. No pictures of scratch work means no partial credit. And that can be pretty lethal because there's a lot of places where one thing can go wrong and you lose all the points. Like on this one, let's say for some reason instead of 0.62 you wrote 0.26, temporary dyslexia. That would mean everything else would be wrong, probably. I don't know if the decision would change, but in the homework it would, or on the online test, it would just go wrong. But if I had your scratch work, I could look at it and go, you know, you did everything correctly, you just made a transposition of digits error. I'm going to give you most of the credit for the problem. So please make sure when you work your final exam to write down everything and send me pictures of it. Text me if you have any questions. I hope these videos have helped you.